We're working on page 5 at the bottom of 5.2. We had just done double bubble in the numerator, GCF of x squared in the denominator. Oh, and I remember another thing I wanted to show you. That is the same thing as x times x. I like to expand them out because see how I'm going to have something up there that cancels? So rather than write it as x squared, I write it like that when it's a GCF. Then we took an x common out of the numerator and we had a difference of squares, which turned into this. Square roots added, square roots subtracted, and then down here we just had a GCF. So we were just getting ready to cancel our common factors. So x minus 5 divided by x minus 5 is 1. And I can tell you, most people that miss these on the test, it's neatness. They can't read their work. They couldn't see something and they forgot to write it down. Maybe missed a sign. So make sure you write nice and big on your paper. Have plenty of room so that you can easily read what's left. So a lot of students miss this because, like I said, this is just like number 3 on the test. A lot of students miss this, but if you expand this out, maybe it's less likely. X divided by x is 1. So now everything that's common is gone, so let's write what's left. So I have x minus 6 and 3x minus 2 in the numerator. And remember what I said, you don't need to multiply that out, just leave it. We call that in factored form. And in the denominator, all I have left is a 4 and an x. So x minus 6, 3x minus 2, gone, gone, gone. Here I have an x, here I have a 4, so I write it as 4x. So that one is about as close to the test as you can get without me giving you the right answer. Very, very similar to the one on the test. Okay, let's go ahead and go on to page 6. So one more multiplication one. So if you would like to turn off your camera and try one more, get another one under your belt, this would be a good one to try. So the numerator is a difference of squares. Denominator, a lot of students miss this. It's just a GCF. Remember, that's what you're supposed to look for first. So you should never skip GCF because it's always the first one you look for. So y squared minus 49 would be y plus 7, y minus 7. So you guys should be getting really good at difference of squares because there's a lot of them in this chapter. So add the square roots, subtract the square roots. Always minus, always different signs because this is a minus. GCF of 7. So divide each term by 7 and you get y plus 7. This has no exponents and no GCF, so it's going to stay y minus 1. But this one, you should notice, is written backwards. So we need to turn it around and take that negative out. So that'd be negative y plus 7. So negative y positive 7 has a GCF of negative 1. So I put that out in front. Then I divide each term by negative 1 to see what goes inside. So positive y, negative 7. Now it's completely factored because remember, we can only cancel in multiplication. So everything has to be a big multiplication problem before you can start canceling, and you can see multiplication, 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 multiplication. Everything's multiplication. That gives us permission to start canceling. Y plus 7 divided by y plus 7, 1. So it can be numerator and denominator of the same fraction, or it can be numerator and denominator of adjacent fractions, as long as there's a multiplication in between. So now it's looking like we have y minus 1 over negative 7. 7 times negative 1. So y minus 1, you can take the parentheses off of that now that that's gone, and then 7 times negative 1, negative 7. There's my answer. We really don't like the negative with the denominator, so maybe a better way to write it would be like this. Put it out in front, and then it's y minus 1. Remember, if you put it up there, then you need parentheses. So that's why I stopped myself from putting it up there, because I don't like writing it with parentheses. So just move it out in front, because calculators and Alex don't really like them in the denominator. So move it out in front, same thing. So let's just write better. Although they're both correct, this is a better way to write it. Okay, let's take a look at division, and you're going to see division is almost the exact same thing as multiplication with one exception. So to divide fractions, we have to multiply the first fraction by the reciprocal of the fraction that follows. What my students and I came up with in class for this is keep, change, flip. That's what this is saying. Multiply the first fraction. So I changed division to multiplication. Keep the first fraction the same. By the reciprocal, flip the second. And so then we shortened it to KCF and said, oh, we'll remember this. It's like KFC, but it's KCF. But then we all got hungry. But oh well. So keep, change, flip. So that means keep the first fraction the same, change to multiplication, flip the second. Because what teachers have noticed over the years or decades or whatever is that students tend to flip the wrong fraction. So that's why my class and I, we kind of came up with an acronym to help you remember which one stays the same, which one flips. So keep the first fraction, change to multiplication, flip the second fraction. So you can see I have done that here. So 5m minus 5 over m stayed 5m minus 5 over m. So let's just put this right above. Then we change to multiplication, and then we flip the second fraction, and you can see we did do that. Guess what's the number one mistake on the test? Students don't flip. They just change it to multiplication and they forget to flip. Or maybe they don't see the division and think it's multiplication because it's side by side with the multiplication one. But if you don't flip it, there's no way you can get the right answer. So the minute you see division, that's when you should go into keep, change, flip mode. Okay, no other time, just division. So then we start our factoring patterns. Here we have a GCF of 5. When we divide both of those by 5, we get m minus 1. This is m. Remember how I said with m with squares, work it out. So 5 times m times m. Sorry. And here I have a GCF of 6. So I pull the 6 out and I get m minus 1. And then we're on our canceling spree. M minus 1 over m minus 1, 1. M over m, 1. So what do we have left? 25m over 6. Yay! So just as simple as multiplication, except we have to do that little step right at the beginning. Keep, change, flip. So keep, and let's just keep writing that so we don't forget. Keep, change, flip. So the first fraction is going to stay the same. So 50 x to the 11th over 30 y to the 8th. So keep the first fraction, change to multiplication, flip the second fraction. So 30y cubed is now going to be in the numerator, and 30x to the 6th is in the denominator. So when I see these really giganto numbers, the first thing that goes off in my head is don't factor, just start simplifying, because you don't want these big ugly things. So you guys know that dividing both of those by 10 gets a 0. It's gone. And here we have 30 divided by 30, so this is 1. So then at least we have smaller numbers to work with. So this is what I like to do. I like to write 5 x to the 11th, y to the 3rd. So 5 times 1 is 5, x 11, y 3. In the denominator, I'm going to have 3, x 6, y 8. And then we can use that little trick that I showed you earlier. Remember how I said keep the variables on the side where the larger exponent is and subtract. So this is going to be 5. See how my exponent's larger there? So my x stays in the numerator and I do 11 minus 6. Over 3. See how the larger exponent is in the denominator? So I keep the y in the denominator and do 8 minus 3. So that's a nice little shortcut. It cuts out a whole entire step if you remember that rule. So keep the keep the variable on the side where the larger exponent was. So larger was in the numerator, subtract. Keep the variable where the larger exponent was, larger exponent denominator, subtract. And so now we get 5x to the 5th over 3y to the 5th. Nice. So that just saves a step. You can do it the old way where we subtract numerator minus denominator, and then you'd get y to the negative 5, and then you'd move it down. So it just adds another step. This just took that step out. But we get the same answer. So even if you continue doing 3 minus 8, y to the negative 5, you would move it down and get what I have as well. Okay, one last problem on page 6. So we have difference of squares. Well, let's go ahead and do keep, change, flip first. So change to multiplication, flip. This is really a boring one, actually. I would never give you one like this on a test because only one thing can be factored. I mean, this is about factoring. So what good does it do if only one thing can be factored? I know this can't, I know this can't, because there's no exponents, no GCF. So yeah, this one's really boring. This is a difference of squares, so it'd be z plus 9, z minus 9, and I kind of like to put this there too at the beginning just to remind myself to flip it. And then I can check back and make sure I did, since I know that's the most common error by students is forgetting to flip that. And then we have our z. Then this is z plus 7 over z plus 9. Only one thing cancels, so this is about the most boring problem in the nation. But somebody's got to do it. So the final answer is numerator z minus 9, z plus 7 over z.